This is the second time we've had beers with engineers in conjunction with Perth Data Engineering at the AWS office. And I think we've got just as much people here this time than last time, which is awesome. Quick agenda. So we've started, what is it, 5:30 now? So we're kicking off. We've got 3 talks tonight. One, I'll go through the names in a second, but we've got a talk on PI data protection. We have another talk on live highway traffic monitoring. And the final one is data infrastructure as code with Snowflake using the Terraform provider.
Oh, pizza's 6:30.
And pieces at 6:30. I didn't add that in there. Most important part. So here are our presenters tonight. Oh, crap. We have Rachel, Luke, and Matthew. So thank you so much for volunteering to speak tonight. We're always chasing volunteers for speakers. So if you are interested, definitely head to the website, speak to John or myself. If you're not sure what to talk on, we can definitely help you with that. So we do have some news that we want to share with everyone. So if anyone's aware of Data Engineering Bites, it's been held over East for the last 2-3 years now, which has been extremely successful. Like last year, they flew out Joe Reese from the United States to come and speak, and we're having it in Perth this year in August. There's the QR code there to the Data Engineering Conference website. You can go check that out for more information on where is it going to be held, sponsors, so more details for if there's any vendors looking to sponsor for the local one anyway. It should be awesome. And we're also looking for people to speak at the conference as well. So it is in August, but again, if you are interested in speaking at the conference, it's a really good opportunity to like rub shoulders with some of the other more like prominent speakers in the industry globally. There's a dinner as well, I think, is there, John, that you get to go to, and that's only for the speakers and the organizers. So please, if you are interested in speaking that, reach out to John or myself. I want to thank AWS for hosting us tonight. We can't have these events without sponsors who put up the beer and the pizza and especially the venue for us. So I want to thank you. Where's Nigel? Nigel, did you want to say anything?
Yeah, I'll just 2 minutes. First, John and Ash, we really enjoy partnering up with the Data Meetup group. So thanks very much. It's always lots of fun.
Awesome.
To the rest of you, thanks for coming along to our house. We love having you over here. Feel free to enjoy all the food and the drink and everything that's out there. We'll have the pizza coming after the session, so be ready once we've finished. Not to put too much pressure on the presenters, but there's lots of pizza waiting up. Bathrooms are just out through the entry door. So when you came in through the lift, go back that way and to the left. And also just for the AWS people, if you can just put your hands up. These are our AWS people. We've got Luke at the back over there as well. If you've got any questions about anything or want to connect with us, we love talking to you about all fun, interesting, difficult things. So feel free to come up and say hello. We would love to talk to you. So yeah, that's all from us. Thanks,
Awesome.
Ash.
Thanks, Nigel. Well, that's it from me. I won't be speaking much more. So without further ado, I'm going to ask Rachel to come up and present the first talk on PI Data Protection 101. Sure. I'm going to unplug. Presentation.
Can you see it?
Not yet. Have you pressed share?
Yes.
Oh, sorry. Yeah, I see it. Yeah, we're good.
Yes. Cool. Let's start.
So before I start, just want to do a very quick survey. I assume a lot of us are data engineers. Please raise your hand if day-to-day your processed data contains PI. Thank you. A few. We will explain what is PI, and you will be surprised. A lot of data we are handling are actually PI data. So my name is Rui Liu. I'm a solutions architect here based in Perth, and I'm an old friend with Data Engineering Meetup. Today's session, what I want to do is to raise the awareness of PI data protection. As a data engineer, especially, when we protect the PI data, we are not just protecting, this is too loud. Hello? Okay. So when we protect PI data, we are not protecting our customers' privacy. In the world, somewhere else, there is another data engineer who might be processing your own PI data. That's why it's very important. At the same time, what we want to focus today is to make sure we can build a strong foundation that can help you to run large-scale machine learning use cases. So let's start. First of all, what is PI? So here I listed a government website definition, information that can be used on its own with other information to identify, contact, or locate a single person. So from this definition, you can understand a lot of data like email address, home address, or your mobile number, or transaction information. All these are actually PI data. And why protecting PI data are important? I do not want to emphasize the importance, because last year I was very angry. So a fraction of my personal data was leaked. And after that, I started to receive very sophisticated phishing email. So we all know that it's very important. That's the reason there are laws in place to regulate how you protect PI data. In Europe, they have the GDPR, which is a law in place to protect PI. And in Australia, we have the Privacy Act. And also, if you are practicing or your system runs in health industry, you need to comply with HIPAA, which talks a lot about how to encrypt the data at rest and in transit. And NIST is a very common referenced compliance in security. It has a specific section to talk about how you protect PI data. Now we understand what is PI, why we protect PI, but how. Now let's step back, look at a very common use case with machine learning. On the left side, we have a bunch of different business systems, and each of the systems have different users, and each of them only contains a fraction of your business data. On the right side, we have our data scientists who are using the cutting-edge technology, algorithms, trying to build models to do predictions. And they have all kinds of different use cases. Fraud detection, customer churn, and all kinds of you can imagine. And each of the use cases need different data that extract from different business systems. That's exactly why we have data engineers sit in the middle, who can help to extract, load, and transform this data to fit in different use cases. Now, let's imagine the source system has PI, and we don't handle PI at all. What will happen? Because our centralized layer, which is our data warehouse or data lake, will end up containing aggregated all of the PI at a central place. And for example, if you do customer churn, which is a very common use case, what data you need? You might need that customer's transaction history could potentially contain its email address as well as credit card, and customer profile, which may be from your CRM system. And if you do not handle the PII, the customer churn model will produce a list of email address you need to hand over to the marketing team to send a promotion. And you are dealing PII everywhere in this pipeline. Can we control the access? Of course. The source system have its authentication and authorization to define policies, and each of the different business users, depending on its role, have different level of access to your data. We can apply the exactly same approach to our lake layer. In AWS, what you can do is use the lake formation, which is a cloud-native tool. We're centrally managing across all your AWS organization, across many different accounts. And to step further, you can use Amazon Data Zone, which is a newly launched service, to make that management easier, because you can allow business user to log in to say which part of data I want to share. But once you do that, you still feel this is more BI-facing use case. Because with data scientists, the machine learning is quite unique. They aim to find patterns from data. If you limit data scientists' access to the source data, you are literally limiting the machine learning capability. So that is the challenge. With this challenge, there evolved different techniques to help solve the problem. The first approach we want to introduce is called dynamic masking. The dynamic masking approach is very straightforward. The idea is you label which column have the PII, and then we mask those data. And when the data scientist is trying to retrieve the data from the lake, the data is already masked, so no PII being reviewed. It's doing in real time. For that purpose, last re:Invent, AWS launched Redshift dynamic data masking. So with the dynamic masking, customer can define what data they want to mask. In this example, the customer phone number is labeled as PII, so you mask it. And it also supports how you mask the data. So in this example, only the last 4 digits is masked. And it also allows you to put very flexible rules to define how you mask the data. So in this example, it's not masking all the phone number. We used another column, which is called geolocation. So for this user, it can still see the WA-based customer information. And for other location, the phone number will be masked. But if you look at it, you still feel it's kind of BI use case friendly. Why? For example, nowadays, the lakehouse architecture, data mesh, is very popular. How you guarantee your data all sits in a single source, right? If you end up have your data, some sits in the data warehouse and some sits in, let's say, S3 as Parquet. How you correlate this data across different sources? And because correlating data is so hard, same time, when data scientists reach out to us, how I verify my performance of my model, it's very hard as well. Because imagine you have a customer churn and you populate this list of email address. It's all randomly masked. And what you will do is you have to put effort to design your underlying data structure properly, that you can allow the model to label some of the columns to communicate with the business user properly. And also, in this approach, because all the data landed at the lake layer as is, so you need to put effort to make sure your proper access is set up properly. Otherwise, you will end up in real trouble. Now, to compare with that, we want to introduce another approach, which is called static masking. So compared than the previous approach, we shifted the masking step to the left, which happens before you land the data into your data lake. To achieve this, we also want to introduce a layer, we call it PI data treatment layer. This layer consists of 3 steps: classification, catalog, and PI treatment. The ultimate goal is to make sure these 3 steps should be automatic. So any raw data coming through these 3 steps should be de-identified and then land to your lake. You might ask, according to data lake, the ELT approach is more trying to delay the data transformation. But remember here, we are trying to do minimum transformation to the raw data and for the privacy protection purpose. And it brings us a lot of benefit. Let's take a closer look. The first step is classification. So classification, the purpose is to find out, do I have PI in the source? And if I have, what type of PI it is? And because we want to try to make it automatic, I will introduce a few cloud-native tools to help with that. The first tool is Amazon Macy. So Macy is a tool that can continuously scan your source data, classify it, and label it. It uses machine learning. It can also use regex. So for example, if you say my customer ID is a PII, then your customer ID have a pattern, then you can use regex to define it. And then Macy will continuously scan your source data and classify that. The second tool you can use is Amazon Comprehend, which is a pre-trained model. What you will do is you sample your source data, feed in Comprehend, and Comprehend will return saying, okay, this is an email address, or this is an address, phone number. The third tool you can use is Glue PI detection. Just be aware this tool currently is under preview. So you are not limited to just this list of tools. You can use whatever tool you already got, as long as it can tell if there's PI and what kind of PI it is, and human hands-off. The second step of the processing is catalog. We know if there's PI or not. We know what type it is. We want to store that information. With that, you can use your existing enterprise data catalog tool, or you can go cloud native, use Amazon Data Zone, or you can build your own metadata storage using DynamoDB to save this information. And the last step is PI treatment. That's where we do the transformation. With this, there are multiple tools you can choose from, whether you use Glue or use DPT, which is very popular in this community, as well as you can use AWS EMR. How we treat it, let's take a closer look. Because we mentioned we want to correlate the data downstream across multiple sources, then it raised the requirement that you need to make sure you process the PI data consistently. So here I give a few examples about introducing the PI data treatment rule. You need to put this rule design in place to make sure you handle the data consistently. There are common rules like, for example, date of birth, delete the date, remain the month and year. Credit card, mask everything except the last 4 digits. Or email, name, and customer ID, just hash it. If you're looking for more guidance, here I listed a government website where it's hard, but it's easy. You just Google it. There are a lot of guidance about how you can treat different type of PI data. We mentioned about hash. So hash is a very important mechanism used here. We want to take a closer look. So here we say hash, we are not just doing hashing, we are doing crypto hashing. Crypto hashing is exactly the same technique we use to store and protect a customer password. So with this approach, we design a master table at the left side. Why I say left side is deliberate saying this master data table contains PII and the data scientists do not need to have access to it. What the table serves is for each of the individual customer, you need to generate a unique sort key when you do the hashing. That protects that some attackers to reverse engineer your hashing algorithm and reverse engineer all your data. That protects your source data. Let's put everything together. So to treat the PII, we need 4 inputs. We first need to know from the catalog, we know where is our PII and what type it is. Second, we need to have a design in place to consistently treat the PII data. The third input, also we need raw data, of course. And the last input would be you have a master data table to handle all the hashing requirements. And with that, you will get a lake with all the data already de-identified, ready to support your various machine learning use cases. So in this example, the data scientists retrieving the data from data lake build a customer tree model, and the result will be a customer email address list. And all the email address is already hashed. They just hand over this table back to business user. Because business user have the master data table access, you can populate Automate 2 to use the sort key, compare and get the original list of email address. And this makes the managing of access to your data lake layer much more easier to support different use cases. At the same time, classification, catalog, and PI treatment, the 3 steps I mentioned here, are not too binding at all. You can use whatever tool you already have, as long as you can finish the steps. You might notice I have a column in the master table called something like expiration. That's very important, and that is another benefit brought by this static masking approach. So with the data privacy law or PI data protection, sometimes the company will be asked to retain the data for a certain number of years. Sometimes you have to delete the data. For example, in GDPR, consumers have the right to be forgotten. If they raise this request, you have to delete that customer's data. Imagine we are using dynamic masking. What do you have to do? To delete a customer's data, you have to dig into your lake layer and delete that customer's data permanently. Those pieces of data cannot be used in your machine learning model anymore. So if you use dynamic masking, that becomes extremely easy. Because crypto hashing is a one-way approach. Without a sort, you cannot recover the data. If a customer needs you to delete your data, what you need to do is just go to that master table, delete that sort key, all done. And your data scientist can continue to use the same set of data, the same way they used before and after the data expiration. So that is very powerful. In Australia, currently, our Privacy Act do not have similar clause yet. But the right to be forgotten has been a very hot topic in cybersecurity domain. That's why we think the static masking, this approach, could be very helpful to help you think how to design a data platform to be future facing. So in general, I talked through two different approaches. When you have PII in your data and you construct a data lake to support different use cases, dynamic masking, static masking, they both have use cases. For dynamic masking, if your data only stays in single source, no correlation required, and you don't care about expiration. And also you have limited volume in a smaller team as you need to manage the access to the data that contains PII. And the static masking instead is a purpose-designed, very powerful approach that can support you shift left with the PI processing and support train the model using the data contain even expired PI. And it's more suitable for large volumes of data processing as well as multiple machine learning teams. So that's all I want to share tonight. Hope you enjoy it. And I don't think I have Q&A time.
You have time.
Oh, okay, cool.
Yeah. Time escape.
Any questions?
What kind of skills do you use on AWS to safeguard your data on the data lake?
What kind
What
of?
kind of skills? Is it something that like a data governance team can get involved in, or is it more of an engineering task?
I think it's more engineering task, and you need to put the design in advance. Also, it's not what I say here is it's not too binding. So that's why I focus on those 3 steps. You can say even you run this on-premise, same. What you need to do is to make sure you have the confidence you can delete that data but still extract value from it in the future.
If I understand well, so what you're saying is you're not. So let's say I want you to forget about me in your database data warehouse. Technically, you're not removing my data. You're just making them unidentifiable.
It's called, yeah.
Yeah. So
Yeah,
you're
you're
not
right.
going in there in all your data lake and deleting every single instance. You're
Because
just making it not connected to me.
yeah, exactly. Because from the definition of the PII, it's be able to link back to the person. Because we process the data before it lands into the data lake. So once you delete the sort key, the data already cannot link back to the person. That's the reason you can continue to use that piece of data.
Do you know if that's like GDPR agree with that approach, or is it in line with what they are doing?
Yes. Of course, it's not as simple as I described here. Yeah, different type of data. There are a lot of consideration, the design, like what I mentioned, date of birth, deletes the date and remain the rest. Maybe you say I want to delete the month and the date. So, and also how you protect the credit card, there are different designs in place. But overall, this would be a mature approach being applied in industries that handle sensitive data.
Awesome. Thanks, Rachel. Super relevant with all the data breaches going on. My advice, everyone, don't bring data in unless you need it. Or happy to see it on the front page of Perth Now. Next up, Luke is going to run us through real-time Perth traffic monitoring. Something like that. Thanks, Rachel.
entire screen would be, or
Easier.
no, you're thinking you're right. Window, yeah.
Yeah. Yeah.
Is that present the view or?
And then, no, I think I just need to come back here. Essentially, I think if I do that, it should be correct.
No, I can only see your presenter screen.
Actually, let's just try to here. I do that again.
I think go back to StreamYard and then share this one.
Let's pull this to my screen. It'll be easier to see what I'm doing without breaking my neck. I like to still make this full screen if I can there. Yeah.
Good job. Can you see it?
Try now.
Oh yeah. Yep.
Good. Just a quick check. Do I even need this microphone? I'm just going to try and switch it off first. Okay, that's off. Can you still hear me? Or would you prefer the microphone? There were times with Rachel where there was a bit of reverb, so okay.
Microphone. I think microphone's better.
Microphone's better? Okay. Pop on my neck. Still all right? This feels really awkward. No, I'm going to have to do that so I can get that reverb. So, hi, I'm Luke Huntley. I was one of the students from the first data engineering camp cohort. And I'm here today to basically present the capstone project that teammate Anoop Anand and myself worked on. However, for this presentation, I did make a few tweaks.
Maybe put it further away. Further away.
Okay, I'll try that.
That's better.
Great. Okay, so the objective of the project was to basically create a streaming data pipeline and a real-time analytics solution. So without further ado, I'm putting the image on the right there. I just want you to visualize traffic on the Quinana freeway flowing northbound and southbound to and from Perth CBD. And at a point, there is a gantry of cameras overhead, and as the vehicles pass by, the details of the vehicles are captured, and near instantly the data is presented on a live dashboard. So with that project objective, some guidelines to help us get through the project, we decided to create a traffic monitor. And so the purpose of the project was to build a real-time traffic monitor that could basically analyze the vehicle details, monitoring their speed and the congestion that is being created on the roads. Target audience that this value data might be valuable for would be transport and infrastructure planners as well as traffic enforcement. And then the desired insights that could answer certain questions would be, do we need additional road upgrades or public transport and or additional type of speed enforcement through cameras? Here is a high-level solution architecture of the tools and services we use. For our source data, we use AWS ECR and ECS. For ingestion, we use Apache Kafka. For our storage, we made use of a Clickhouse database. And for transformation, we created some SQL views, which were deployed from dbt core, triggered by CI/CD pipelines. And then lastly, for analytics, we used Preset Cloud for Apache Superset dashboards. So for our source, it proved to be a bit of a challenge to find a live streaming data source. So we opted to build a Python script to generate data using the Python library Faker. which would create a vehicle object with some additional attributes such as the travel direction, the speed, and what else have I got there? Number of passengers and a few more others. To try and make it realism or add some realism to the data, we play with time delays to try and model fluctuations in traffic through peak and off-peak hours. Using Confluent Kafka Producer, we publish the JSON object messages to a Kafka topic. We implemented schema registry for some data consistency, data contracts. The whole producer script is containerized with Docker and stored on ECR. And then that ECR image is run on ECS on a Fargate service. And lastly to mention is our secrets are stored in a .env file on an S3 bucket. For ingestion, previously mentioned, we use Kafka hosted on Confluent. However, we could have probably used Amazon AWS MSK for managed streaming for Apache Kafka. The core object messages that are produced and are published to a Kafka topic, as I said, and then using Kafka Connect HTTP sync connector, we push the messages to a database. So for storage, we use the Clickhouse database on Clickhouse Cloud. Clickhouse is considered a real-time database. It is a high-performance column-oriented SQL database management system for online analytical processing. It's designed to ingest data very fast and run queries, predictable queries, within milliseconds to seconds. It's optimized to processing large data sets with billions to trillions of rows, making this popular for real-time analytics. So data received from the HTTP sync connector is inserted into a raw traffic table and stored as one big table ready for transformations. I'm going to take this moment just to dive a bit deeper into the different types of databases. So here I'm comparing three of them, real-time, OLAP, and OLTP. You guys are most likely aware of mostly OLAP and OLTP. So I just want to sort of shed some light on real-time, but just to go through each of them. For the purpose, let's go on to OLTP. Very fast account operations, you can find these usually behind some kind of application of a sales system or an inventory system. And yeah, I think that's it. Basically used to be stored and processing transactions that are happening as they're happening. We're looking at OLAP. The A sort of mentioned is for analytical. These are got a use case of servicing reporting use case. Basically, it's a data from an OLTP and other data sources. Other data sources are ingested into an OLAP database through batch jobs that regularly run, and in that process, the data is transformed and some aggregation is occurred, some tables are flattened, and making that ready for reporting. Additional point there is this is fast for most query patterns. This is because you have various users across the business that are writing their own queries, flying their own joins, so we don't actually know each query that the user is going to write. For the real-time databases, the purpose is for real-time analytics. Data is usually from a streaming data source and it's ingested as the events and messages are occurring. This is more for a reporting application, specifically where certain queries that are predictable queries are run for those charts, if that makes sense. And yeah, it's very fast for that. Just going to the next row there, looking at storage and compute, coming back over to OLTP. Storage and compute are coupled in most cases, using row-based file format, and where performance is increased through vertical scaling, through additional large compute. Going to OLAP, storage and compute are decoupled in most cases, using columnar file format, which is more for analytical queries. And horizontal scaling is more performance increase through horizontal scaling through additional nodes on a cluster. Usually they share in the same data source. Whereas on real-time, storage and compute are coupled for better performance. And also using columnar file format, again for analytical queries, and horizontal scaling is through shards. Yes. And moving on to indexes and optimizers, we have our TP again. Indexes are built during ingestion, and it does have a built-in optimizer. OLAP, there's no indexes. Instead, metadata statistics is used with the query optimizer. Looking at real-time, indexes are built when data is ingested, since indexing does help with the speed of performance of running queries. However, it may not have an optimizer. I think that's the part I mentioned. So I should forget to mention the real-time database. Your predictable queries that you write, this technically means that you need to design your data and your tables in such a way that the queries actually run fast, since there is no optimizer. May not be optimized. Going back to the project again, for our transformations, we did data modeling and data quality tests using DBT Core. This was deployed by CI/CD, GitHub Actions, as there was no real need for an orchestration tool like Airflow. And lastly there, since our data is stored as one big table and the database that we're using is designed for real-time analytics, staging and serving models are materialized as views instead of tables. So for analytics, we use Preset Cloud to display Apache Superset dashboards. We connected to the Clickhouse data source and then queried the aggregated serving views to present the dashboards, and some I have put there is a previous 7-day traffic monitor, I've got a previous 3-day carvers, passenger count, car age, you'll see it in a moment, car makes and fuel types. But I think most important there is the live traffic monitor showing today's data, which is refreshing every 10 seconds. So that's a slide back there. I'm going to go into a bit of a demo now, looking back at the solution architecture of all the tools and services that I use, just looking over some tabs. Extending the screen, do that. Okay, with me here. So, as I mentioned for the source, we're using AWS ECR and ECS. So this is just showing you that our ECR repository contains basically our Docker image. That Docker image is then being run within ECS cluster, and here is our traffic Kafka producer running as the service when the container is running. Just quickly going over to CloudWatch, we can see some logs that the Kafka producer is producing. Open this one over here. So here we can see the records basically being inserted into Kafka. Record with the license plate, and then showing you the topic that it's going to, and the position and the offset that the message is at. Just moving over to content quickly, here we have our traffic monitor topic. Just want to point out here on a message. I'll open that new message there. Here you can see it's called the car object in a JSON format, where you can see the license plate, the color, type of car. Quickly moving over to the HTTP sync connector, the Kafka Connect. You can see it is running, and these are the messages that it's produced in the last 7 days. Next slide here, tab is the move on to Clickhouse. So now we move to storage. And here we have basically the raw traffic table where the messages from HTTP sync connector are being inserted into. Again, linking to that JSON object. Now we have a table with the year, model, make, category, license plate laid out over there. And going now into the transformation where we have SQL views. Rewind slightly, sorry. Just want to show you that we are getting data into the database. I'm going to run this count very quickly. A41295. Run it again. 1307. Yes, that is increasing. Now moving on to transformation. Just want to point out here are our views. I can see what I'm clicking on now. So we have one staging view at the bottom here, and then a bunch of serving views, which read from that staging view essentially. Then just want to touch on our GitHub Actions with our CI/CD. Since those views are created from our CI/CD pipelines, we have two pipelines, a integration pipeline and a product deployment pipeline. On our integration pipeline, I just clicked on the previous one that's been run. Here are all these steps that it's taken, but most I want to point out that this is triggered on a pull request when you work on a feature branch, it's needed to request to merge into main. So when that request is sent, this pipeline will kick off and doing a bunch of things. But the one I want to point out would be, you can see there's some SQL linting that takes place, as well as then a dbt run and dbt tests, making sure data quality tests. And should this succeed as you wanted to, that's when a reviewer can review the code, looks good, and approve the merge. Looking at the deployment pipeline, so this is triggered on a workflow dispatch. Basically, there's a button there somewhere, sticking up here, where you can then, when you're ready, if you want to, deploy it to your production environment. And I guess you could have other pipelines for different environments should you want. This is broken up into two parts. The first part is to build the Docker image and push it to ECR. And then the second part, basically, you need to update the task definition with the new ECR URI, and then push it again, and that'll deploy into production. Deploy and push to ECR definition. So then coming to the actual real-time analytics, these are some dashboards I created. Just want to start over there. Going over to the first one here, just want to point out that we analyze the traffic northbound and southbound. You see the theme left and right on each of the charts. This is fake data, nothing fancy, but just the first chart, playing around with preset charts that you get is just looking at the manufacturer year of the vehicles, the entire data set. And below that, we've got a word cloud of the vehicle categories that are here. And you'll notice that they're very much similar charts on each. And I think that's the fake vehicle provider that's weighting certain data more than others. The next one here, first one's not using the vehicle provider, just a random generator of these three, evenly distributed. And underneath that, we have a tree map of the vehicles that are most popular. As we can see, Chevy seems to be a popular car make. Another one here, previous 7-day traffic. First little chart there showing when max and average for each day. And underneath that, we have a vehicle count and passenger count. Notably, I'd say the dip that you see here is related to weekend traffic, just dropping as expected. And you have a previous 3-day passenger car counts. Purpose of this was more just to show we are attempted to model the fluctuations of peak and off-peak. So if we do come looking at these little dips over here, this would be at the early hours of the morning, expectedly. And then at 5 a.m., 6 a.m., we have a big spike as traffic increases before it drops off again. Before lunchtime, where it picks up again, and then drops off just before the afternoon rush hour takes up again. And lastly, this dashboard here is the one that is refreshing every 10 seconds. Notably, you'll see with the cards at the top of the passenger count and car count being refreshed. And you may see the average speed increasing. May just draw attention to the car count, passenger count. So this is technically the end of the presentation. Coming back to the slides here. Yes, I would say, is there any questions? Oh, yes, there is. Okay, go ahead.
Okay, so my first one was going to be about like your transformation, if they delay your real-time process, but then I figured out you created views. So now the question is, are the views slow because they're views, like basically you need to pre-process?
I'm going to say no, they're not slow. The point of using the real-time database is because it can process those faster. The way I want to say the real-time database works is through those shards. If I understood that correctly, is because computer storage is coupled. There's multiple instances of those, let's call it nodes, and each storage version of that is only hosting some data, not the entire data set, and therefore it's able to aggregate and compute that a lot faster.
And then my next question was, you said like you're using fake data.
Yes.
Like, are you planning to connect it to real-time traffic data? Like, is it already done?
No. So it was a challenge to find real-time data. So I did find some data sources within Perth. There is actually traffic monitoring, but it's not live. It's called it's not historical. I didn't see how often it gets updated. For the purpose of this, I wanted data that's being generated like right now. So there was a way for me to, I could have perhaps used real data. I just would have to have sort of slow the speed at which it's being inserted. It's an idea. I wasn't planning to do it though. You can do it next.
So this is like a proof of concept project.
Yes. So just touching on the data engine camp that I was, the boot camp that I was on, the first two projects that we did was very much batch streaming, batch processing that we did. For the last one, we wanted to make use of the additional tools that we learned, which was a streaming data source. Yay, and then we couldn't find the streaming data source. So like, what do we do?
Awesome.
Thank you. Yes.
My question is around number of passengers in the vehicle.
Yes.
Would that be realistic in real-time sense?
So what I did there, originally I think there was up to 5 passengers in a vehicle. Imagine the cameras had X-ray and could look that deep into it. But I think I went for 3 passengers at one point. But it's a random value. And when I say random, it's actually not random. What I've noticed with the data set is when you're asking a random generator to choose between 3 values, it seems to evenly distribute that by just like 33% each time. So I'm going to say no, what you want to answer there. Yes.
I'm guessing you got to take the job after boot camp. Yes. Yeah, follow up then is, how have you used any of this in your actual workplace in the context of
Tough questions. No, haven't landed the data job following the boot camp. Open to work.
Yeah. Sorry for your
You won't see that on LinkedIn though, because I do enjoy the team I'm working with now. As for how I use it in my current role, I don't. If you go look at me on LinkedIn, you will see I have got a data engineer role, but it's not quite a data engineering role. I guess a lot of people have these titles and they don't necessarily do the work. There might be more data analyst work. Mine I have is more comms engineering work. I come from an electrical engineering background I consider myself more an engineering technologist, and took this course to as a bit of a pivoting career, since I always enjoyed working with data and dabbling with coding and learning new systems. Yes.
Yeah, that's a cool solution. I really like this. Can you give us an idea of how much running this would cost? I'm genuinely curious. You don't have to go in details.
Depends what costs you're looking at because there's different portions of it. Right now, it's in the AWS costs are quite low, thankfully. Thank you, AWS. Unfortunately, the Confident one is my highest at the moment. So I've been running it for 3 weeks and that's spent about $60 US. But yeah, US is far than that. Clickhouse, I am using the development version of it, or should I say the pricing of it, and also hosting it in chosen US, Oregon location, also for cheaper costs.
Right.
I'll get to find out what that costs. But there is pricing in it to show you how much you're going to pay for storage and compute. If the company's paying for it, it's fine.
Yeah.
Yeah, we have to dive deep into the actual pricing and then calculate if you run it 24 hours a day, what it work out to. I didn't do that. I pop my credit card details in, use whatever free credits we had since, well, actually, through the course, I used all my free credits. Then I had to use my credit card. Any other questions? Yes.
What are you using for the schema registry?
So Confident has a schema registry. I've used their one. Yes, on the value, that was one of the additional changes that I've made. Bit of a challenge in the beginning to implement it. No, we're using a JSON. Using JSON or JSON schema registry. Yes. I think it supports Proto, if I'm not mistaken, and Argo. I haven't dealt with those yet. Trying to get the project ready before I've been learning too much new things. Cool. I think that's it.
Awesome.
Thank you.
Where's Matt? Matt is up next, talking on data infrastructure as code with Snowflake and Terraform.
Ash, do we want to break for 5 to get pizzas or?
It is entirely up to everyone.
Has it arrived yet?
Do we want to have the last talk, then pizzas, or quick break?
Grab that and come in?
Yeah. Raise your hands if you want to get pizzas now. People want to get to the top. Right. Sorry, John. Yeah. And yeah, Matt, you're the person behind everyone getting pizza. So.
Don't worry, I'll try and be super quick.
No, don't rush it.
Potentially something's been unplugged here.
Okay.
I think potentially this thing has been unplugged.
Ash, could you give him a hand?
I can't do it.
Matt, yeah.
Less plugs in this. That might be it.
Hey?
I got it, sorry.
No, it's more if you've gone through the permission stuff that I failed to do.
Okay.
Did you do that?
I don't remember any mission stuff, but I had it working just
Yeah,
earlier.
I think it's good.
It's good?
Yeah.
All right, just yum the community.
No worries.
You're going to use one light right switch it off for a moment. Okay. Green light.
Is this required for the online thing?
No.
Can I please potentially?
Not use that?
Yes.
if you're loud enough for everyone to hear you.
Oh, I can do that.
Sorry, have you as well shared your screen? On the,
Yes, sorry, I'm just reconnecting into
Thank you.
the live stream.
Thank you, sir. Yep, you're good to go.
Cool. Okay. Thank you all for coming, guys. I know it's been a long night. 3 speakers back to back is a bit of a lengthy evening. I'll try and be quick so we can get to the pizzas and more beer, the important stuff. Cool. So today I'm going to talk about data infrastructure as code, and I'm going to talk a little bit about how you can do that with the Snowflake or the Terraform Snowflake provider. So I would like to begin with a takeaway, an idea that I'd like everyone here to leave with today, and that's that I believe you should use tools, not your dirty mittens, for database management change. Okay, so what am I going to talk about today? I'm going to give you an introduction as to who I am, because who doesn't like talking about themselves. I'm then going to talk about the problem that data infrastructure as code solves, the potential solutions. Spoiler alert, it's infrastructure as code. Then I'm going to talk about the tooling you can implement that with, the limitations of that tooling, and then I'll have some time for some questions. Cool, so who the hell am I? My name is Matthew Carter. I work for Mechanical Rock as a data engineer. I've worked in data for a couple of years now, both as an analyst and an engineer. A lot of what I'm talking about tonight is part of my indoctrination into Mechanical Rock. I'd also like to point out that I'm not sponsored, but this talk is. And thank you very much to the sponsors and John and Ash for letting me speak tonight. Thank you. So cool. Let's jump into it. So when a company decides to lead the realm of Excel spreadsheets, they generally build a data platform. And in that data platform, they've got what I'm calling data infrastructure. Now, before the cloud, I think it'd be very fair to call data infrastructure as like the physical server racks, the physical disks, the physical CPUs that you've got in the basement with some greasy guy like me managing. But in the cloud, I think that definition is subject to change. And I think that I'd call infrastructure the resources that facilitate data pipelines, as well as the way that people interact with your data platform. Now, in Snowflake, which is a cloud data warehousing storage solution, which is pretty cool, similar to Redshift as well, but I'm not going to get into that debate tonight. Snowflake draws some arbitrary lines around different resources. And one of those groups that they draw out is account level objects. And I think that these objects fit nicely in my definition of infrastructure. So what do these things include? They include things like your security model, your compute, your monitoring, and your integrations with external systems, as well as your users. Now, in managing these bits of infrastructure, if you do it manually, it's very easy to make mistakes. And there are a lot of problems involved with writing ad hoc queries to spin up all your infrastructure. Now, I hear you asking, what are these problems? Well, let me tell you. So there's three main ones that I'd love to rattle off for you. The first one is disaster recovery, visibility or lack thereof, and security risks. So disaster recovery in the cloud, in my opinion, really, I think refers to human error, someone accidentally deleting something. You know, you do hear about stories of data centers breaking, but really today, I think the real risk for disasters is someone accidentally breaking something. You can have security breaches and software bugs that can cause this, but I think predominantly it's human error. And if you've had someone spin up all your infrastructure by hand, it's very hard to bring it back up to that state without going through logs, which is very difficult. Lack of visibility, I think, is another big issue. So you have this like key person or key people problem where you have a couple people manually running the show. You know, DBAs, you hear about DBAs who have run a data platform for 10 years. They've got tenure, but it's not in their contract, right? Because they're integral to that system. And if they leave or they go on break or something, handing over that management to someone else who wasn't part of the development process is very difficult. Tracking changes is also quite difficult. If you've got people running ad hoc queries, manually creating stuff, it's hard to figure out what changes are made. You can go through the logs, but I would call that a tedious task at best. And I also think that you also invite inefficiencies. So provisioning compute, for example, especially in Snowflake, the way that you provision your warehouses, which is the compute, has a massive impact on your costs. So if you're provisioning that in an inconsistent way, you can potentially drive up your costs. Finally, I'd like to talk about security risks. So building an RBAC is a very arduous task. Your security model is something that you want to take care of and make sure it's consistent. And I think that if you run queries in the console to build up your roles, build up your hierarchy, it's very hard to hold that in your head when you make a change. You can go and query your database and you can write it down and you can document your security model, but as people at work say who are higher up than me, documentation, the moment you've written it, is out of date because it's not a reflection of what's actually in your current system. And although I don't think data infrastructure as code solves this directly, I think it mitigates the risk of human error. And that's the point I'm trying to make with these areas, these problems. There's also sensitive data management, which is a headache to design and implement. I've been a part of a team that's done that. And I want that to be right, and I want it to be consistent when I write it. And I think data infrastructure as code can help with that. So cool. I can hear you all clamoring about, Matthew, what are the solutions to this? Well, the first solution that I thought of when I came out of uni and heard these problems, which are a lot of the time they're synonyms for human error, I thought to myself, well, what about just don't make that error, mate? And don't be stupid. It's basically the takeaway that I remember my very arrogant uni graduate mind. That's what I was thinking. And I think if, maybe small businesses, very small data platforms, you can get away with that because it's just you, there's low risks maybe. But I think as you scale up to an enterprise level, it's a lot of complexity to have writing on a couple people that, can turn restricted mode off. My current thoughts on the matter is that you should use infrastructure as code, which I think is pretty cool. So again, I hear you all clamoring in your seats asking, Matthew, what is infrastructure as code? Well, let me tell you. It's managing and provisioning infrastructure through code instead of manual processes. And I think this really encompasses three things. You've got the tools that actually make the changes, but you have to have alongside that your version control and your CI/CD. So version control being GitHub, tracked, approved, easily making changes and rolling them back if you get something wrong. And then your CI/CD pipeline is just a fancy buzzword for automatically running those tools after your version controls all wrapped up and approved and whatnot. So why do I like it? Why do I like infrastructure as code? Well, it's consistent. You've got high visibility of what's going on because your code is living documentation. You've got that version control, you've got approved changes, and you've got speed. You can template the creation of resources, which means you can spin up or onboard a new domain very quickly. And finally, look, Mum, no hands. My dirty mittens aren't making data infrastructure. You've got the tooling doing it. So what are the tools that you can use to implement data infrastructure as code? I think the first one I'd like to go over is database migration tools. So these are imperative change management tools in which you can create basically a lot of scripts that are versioned and you have fine-grained control over your changes in your data platform. However, it's hard to manage at scale because you end up with a lot of verbose scripts. Two examples of this tooling are Flyaway and Schema Change. Flyaway I've used personally. It's a lot of SQL scripts that describe the changes. It's an open source tool. It's also Schema Change, which is in YAML or JSON, which means it's a bit easier to read, so you can handle a bit more complexity, so I'm told, but I haven't used it myself. Moving right along. This is what it looks like. Yikes. There's an argument to be made that you're actually just writing the logs before it actually gets logged. So you've got all this complexity in your GitHub, but yeah, truth be told, you've still got your version control, you've still got your infrastructure in code, you've still got those checks and balances in place, but it's not my fan favorite. And moving along to Terraform Snowflake Provider. This is the tool I want to talk about tonight, and I'm a big fan. Who here has used the Snowflake Terraform Provider? All right, please contain your incitement. I am getting to the limitations. This is a balanced review. So, cool. The Terraform Snowflake Provider is a declarative tool, which means you just tell it the desired state that you want, and Terraform handles the creations, the replacements, the updates, the deletes for you. Oh my God, I'm turning 14 all over again. It also means you have better readability because you don't have all these scripts, these verbose SQL scripts that are making everything and rolling it back for you. And I think that readability makes it more scalable. It's all written in Terraform, which is an open source infrastructure as code tool, which you write your infrastructure in these config blocks, which are super readable. I'll show you that in just a moment. It also handles your dependency. You can do multiple environments with it, and it integrates directly with GitHub, or you can use the API in a CI/CD pipeline like GitHub Actions, which I'm a massive fan of. This is a bit of foreshadowing. This tool is not officially certified by Snowflake. Moving along. They do have a guy from Snowflake working on it. They don't officially endorse it, which is, you'll see why in a sec. This is what Terraform looks like. You've got these nice modules, which are basically just functions, which means you can repeatedly spin up bits of infrastructure in a nice, consistent fashion. You've then got the plan and apply process in which you can see the changes that Terraform's going to make for you. Then you can apply them. It's just a screenshot from GitHub Actions. Cool, and this is how we were actually using this that module in the internal project. This is how we spin up our schemas and all of our read and write access. These modules are repeated for the creation of, these are repeatable modules for the creation of grants. However, I have heard of and seen people have issues with grants in modules, but I haven't experienced it personally. But it's relatively succinct, which is what I love about it. You know, this is a lot of SQL in otherwise, if it's not in Terraform. So I'd like to get into the issues with this provider. So this thing is quirky at times. It's got opaque behavior, and it's got hard limits on the scale of complexity. And what I mean by that is coding's an art form, right? If you want to go crazy, you can go crazy. And if you do go crazy with this, you lose a lot of the benefits of infrastructure as code. You lose readability, usability to make changes fast and whatnot. Cool. So I think this really sums up the next couple of slides quite well. This thing's got 350 issues on the GitHub repo. Does anyone here work at Snowflake? If you're ever in San Fran, I can come and there's one guy working on this in Snowflake, and this guy needs a hug. Like, this guy's being dragged all over GitHub for his design decision making. If you ever see him, please give him a pat on the back and just say it's going to be okay. This is the quirky stuff I'm talking about. This guy, this is what I'm talking about, being dragged all over GitHub. He put emojis as delimiters for a Terraform resource ID, which, man, if you're texting people, cool, use emojis. Please don't put it in a Terraform project. This is the opaque behavior I'm talking about. So this is a grant that, so this is a parameter in a grant resource in Terraform. You know, because everything's a resource in Terraform. The default behavior of this is this parameter is set to false. Now, if you make a grant to a role, say for an account level privilege, and this is set to false, you'll probably be okay making the grant. But if you ever rip that up, it's going to rip up that privilege for all the roles that have it. And I'll let the cogs turn there, because if you've got multi-tenancy and you rip up a bunch of access from different business units, they're not going to be happy. This is a chunk of code that I used on a project that basically checks for this in your CI/CD pipeline using ConfTest. It means that you will never run into that issue. So what is my response to this? Like the criticisms I get from my coworkers, it's got a bit of truth in it. Yeah, it's fair enough. But it's also new. This thing's like a couple years old. It only just got given into the hands of Snowflake, and it's only got one guy working on it. I hope I don't eat my words here, but this is the worst this provider's probably ever going to be. Hopefully. I think it's only going to get better. But unfortunately, the reality is in data currently, and I'm all for, if you guys have got better solutions to infrastructure as code, please come and have a yarn with me over a beer. I'd love to hear it. But currently I can see database migration tools and Terraform providers. For Snowflake, the lesser of two evils, I think, is still the Terraform provider. If you want to talk about, sorry, I'm getting to my final thoughts here, but if you want to talk about Redshift, for example, Databricks, they have Terraform providers and they work. So if you want to go use those, it's awesome. But the Snowflake one's a bit, how you going? But it's getting better. It's getting better. I really like it. I think it's an awesome tool. I think once it's up to scratch, it'll be the best way possible to manage a Snowflake instance. Cool. So, does anyone have any questions? Everyone's hungry, right? No questions? No mech rockers, no ex-mech rockers. So I have to say mech rock 3 times according to my boss because I didn't wear the shirt. So I'm from mech rock. Yes, sir.
So my question is exactly what infrastructure you're spinning up with this, because if you're using DBT, that's going to create what your tables.
So this
exactly which bits are.
Yeah. So this tooling is designed to work in tandem with DBT. So we've used on an internal project the Snowflake Terraform provider, the Terraform Snowflake provider, and DBT. And the infrastructure that I'm talking about is things like your RBAC, for example. Like the role that you would assign to DBT to work inside of your Snowflake instance would be defined in Terraform Snowflake, as well as the privileges that it has. The databases that it's working on would also be defined, as well as the schemas, I think. It's a lot of ways to skin a cat. Coding's an art form, right? I'd also argue that your warehouses, which is your compute, should be managed by this. You can track changes, making sure that there's an approved process for how big that cost is going to be, right? So these are the sort of things I'm talking about in Snowflake. You could probably draw another arbitrary line around Databricks infrastructure and stuff like that in Redshift. But in this context, that's what I'm talking about. Does that answer your question?
Yeah, we use schema change.
Schema change? Cool. Well, that was up there, so good stuff. Any other questions? Yes, John.
Have you looked at alternatives like Pulumi instead of Terraform?
Yeah, so Pulumi sits on, that's an in-joke because we did use Pulumi at one point and failed to get it to work. But Pulumi sits on top of Terraform. So it actually has all the problems that Terraform has. Plus more. Pulumi for like AWS stuff is really cool. Like I've heard a lot of good things about provisioning AWS resources. Doesn't work. Doesn't play nice with Snowflake. We're all
Awesome.
Awesome. Okay.
Thanks, Matt. That's it. I only have one more thing to say is that the tickets, I was told 20 minutes ago, the tickets will most likely go on sale for the Data Engine Conference the next few days. So keep an eye on LinkedIn, I guess. And Matt, where is Matt? I reckon he takes the crown, the most enthusiastic talk we've had today. Yeah.